Well, hi, good morning. Thank you for joining me in my shop here. Today is February 25th, 2024. It's the second day on this radio. So, in thinking about it a little bit, and especially the fact that its operation was very, very weak when I did have it operating, I think the next logical step is to test the vacuum tubes that are in it. There's a good chance the weakness is from a weak tube, and if I find the weak tube and change it, the radio's performance will go way up. On the other hand, if it is a weak tube and I don't bother with it, then I'll be hunting and hunting for something inside this radio that really isn't there. It's really a weak tube. So sometimes I delay the tube testing until quite late in the process, and this is usually because the radio's performing fairly well right at the start. A fair bit of volume and the like. Not this guy. Volume very low. So, we'll start with the rectifier tube, which I'm pretty sure is this one, which is wrapped by all of this. This is not the best arrangement. This is a hot tube, and these wires are going to get heated here. Really quite a mystery as to why he's used. This is lamp cord. This is this stuff he's used in here. So it either indicates that someone who did this work didn't have very many resources available, so they had to settle for using this kind of wire. Why all the tape here? I don't know what they were trying to do, but they did what they did. So, okay, this is the antenna wire hanging out the back here. So this is more for shortwave antenna use. And what is this going to do? It's not going to do anything in my shop here except cause trouble. So I'm going to shorten this. I don't have that hanging out the back anymore. Okay, I said I was going to start with a rectifier tube. Wow, does that ever feel? No, it's just part way out of the socket. I was going to say, wow, it felt like the whole socket was moving there. Should be a 35, I think it was W4, 35Z5. Okay, could be a 35Z5. I'm going to take a quick peek at the schematic here just to be sure that we've got the right tube. I can't imagine it can be wrong. 35Z5 is what is supposed to be in there, and that's what we got. Okay, that's our first tube to test. The tube tester I'm going to use is this one here. I like this one because it's very fast. This is not a dynamic tester. This is an emissions tester, but it's of good quality. And if a tube is weak, it's going to be found with this. Now this is a rectifier tube, so weak isn't quite the right word for it. So we'll switch it on. The pointer comes up and just indicates the line voltage setting. It's supposed to be set to the center here before we start. And 35, looking over here, 35, 35Z5, wasn't it? I'm going to get this, 35Z5. Don't get it wrong now. Okay, 35Z5. Press these two buttons to release any buttons that are down. There aren't any down. 35Z5. So, filament voltage is 35 volts. The buttons in the top row are 1, 2, 3, and the buttons in the bottom row, just button number 6. This gets set to 13, and when the test comes, it'll be the W button. Okay, we'll plug this guy in. Rectifiers, by the nature of the design, wear out fairly early in their life relative to other tubes. Rectifiers and output tubes, they're both hard-working tubes in a radio. They're designed that way, and it was probably an expectation as the radio came out of the factory that somewhere during its life the output tube and the rectifier tube would have to be changed, but maybe not the rest of them in there. So finding a radio with a weak rectifier or a weak output tube should not be too surprising. So first we're going to check for short circuits. If there's a short between the elements in here, I don't think the radio would have worked, but it did. So, but probably no shorts. But nevertheless, we'll run through the test. watching this light to see if it stays on. A little flash is not a problem, just if it stays on. No shorts being reported, and the test for this test button is W. So there we are. Good. She's fine. Okay, that's the first tube done. Right there. Put it back in. So we'll do the output tube next. 50L6. Yep, 50L6. Down we go. 50L6. Here we are, 50L6. Now we're setting this to 50 volts. Whoa. So I have a clamp on my tripod which likes to come loose all the time. Without warning, it just suddenly gives up. Right, where was I? 50L6. Release the buttons. 1, 2, 3 again. And 4, 5, 6. Isn't that fun? 1, 2, 3, 4, 5, 6. 35. And the big dial. This time to test it, I push both W and V buttons together. Ooh, wait a minute. 50L6. That's right. The V and the W together when the time comes. Okay, we'll pop that in. With the radio producing a low output, low volume, there's a good chance this tube is the problem. We will see. Okay, should be hot enough now. Looking again for shorts. And again, if there was a short in this tube, we'd probably already know it. No shorts. And again, the test for 50L6 VW. Volkswagen. Oh, down and falling. So you really want this to come up, they kind of designed this so it'll come up in the middle of the good range, where they have the number 100 written as if it's 100% in the middle. Try it again. WV. Notice when the test starts, the meter's a little higher and then it drifts low. Now, that's probably some interpretable information there, but I'm not quite sure what it means. Well, I think we would class this as, well, I don't know. This probably wouldn't be weak enough to make the radio as weak as it is. Turn the volume right up on this radio and barely hear it. So, but this could be part of the picture. It could be this tube is weak, and maybe the one feeding it is weak. Just down, oh my gosh. So you're supposed to get that out of there. Really? That's not good enough. So when they put the extra speaker in, they kind of buried this tube. Oh, I don't want to use that. I thought I grabbed this. This tube is very, very clean and shiny. Wow, looks like it's brand new. But it does not have the dust on it that these other two tubes. Look at the difference here. So either this guy got polished up at some point or he's a replacement. 12 SQ7. Okay, I'm just going to keep this video rolling here while I do this. 12 SQ7. 12. Which way to 12? 12 SQ7. Here it is right here. Now they're listing three tests in the window here. 3 different tests. Because this tube is actually 3 tubes in one. 3 tubes in one. Or you might want to think of it as 2 tubes. One part is a triode amplifier, and the other part are 2 diodes in here. And they package them together in the tube because it's extremely convenient to the radio designers to have this package together in one tube. Saves on my socket. Saves on my socket. Okay. 12 SQ7. 12 SQ7. Making sure I'm not wrong. 12. 12.6. A234. A234. The bottom road, AC18. AC18. 50. And the test is WX. Okay, in you go. The first test we'll perform, I'm pretty sure, is the tryout. So the tryout here, if it's weak, and then the output tube is weak, the combination could be responsible for the very weak output. Or it could be this guy on his own. Okay, any shorts? No. And the test was W and X. Okay, so it's in the good. It's not way in the good, but it's good. I don't think this would quiet the radio. Now the diodes, you pop the lower row and set it to 5, just 5. We set this to 80. Now we push X. Wow, that's in the bad side of things, isn't it? And we do the other one, it's 6. And we push X. Wow, okay, so all three tests here have indicated not a strong tube. I could be wrong in this, but I believe they share the cathode, the diodes and the triode. They share the cathode. So if the cathode is worn out, I think you would see it on all three tests, which is what we're seeing. So this is probably a worn out tube, even though it looks so nice. Look at that. Wow. How did it get worn out but look like this? Oh, the mysteries abound. Okay, I'm going to put this, I won't plug it right in, I'll just put it in the spot. There. Now we're going to take out the next one. We're just kind of working our way back towards the antenna here. So this next tube is a very important tube at amplifying the signal that's going through the tube. I mean, a lot of the tubes are amplifying, but this one's particularly important. Should be a 6 SK7, 12. 12, Jim. 12 SK7. 12, 12, 12. Okay, 12 SK7 right there. So 12.6. A1246. A1246. And below A, don't get it wrong, A358. A358. 15. I mean, the reality is, if any one of these tubes is really, really bad, then it could easily be responsible for the radio's output being low. And I guess, you know, if all of them are weak in a row, the combination may end up looking pretty bad, like this radio now. Can't be sure because there could be other component issues that are really causing it to be weak. So let's just carry on here. Any shorts? No shorts. It's too cold for shorts anyway. Too cold outside. WY. Well, look at that. We finally got one that's good. That's the entire test for that tube. Okay, so this one is not responsible. It is not responsible. Now, could this be could that be an original tube? Yeah, sure. I don't see why not. Probably most of these radios during their initial normal life had some kind of tube replacement done, and maybe a little bit more work to it. 12 SA7. So I don't know if you can get, daily use, hours every day, if you could get years and years out of these radios before some of these tubes would become too weak. 12 SA7. 12 SA7. Here it is. 2 tests. This is the mixer tube. Depends what's going on inside this particular one, I'm not sure. It could be 2 quite separate arrangements in there, maybe sharing a common cathode again. A12678. A12678. AC345. AC345. 35. WY when the time comes. So the situation is ending up where I'm not going to be sure that the tubes are or are not responsible for the bad performance of the radio. I think this is where we're going to end up. So what I would do in that case, considering where we are with the repair, there's a lot of capacitors to be done in that. And with the radio operating to any degree, I'd probably just put the original tubes back in and carry on underneath. Whoa, there goes my tripod again. Come on, man. Stay there. You know what? Hopefully my audience is not going to sleep like my tripod is. Here we go. And you would be my audience. Audience of 1. Okay. And 12 is this. WY. WY. She's in the good. Okay. Now, to test the other part, we pop all the buttons. And we do 128, 128. Maybe this sort of suggests these are quite separate. 2 tubes in one type thing here. 5, 6. Concentrate, Jim. 1, 2, 8. My thoughts are jumping around. I'm liable to make a boo-boo. And the test is V. And it just goes in the good a little bit. So again, I don't think this can be responsible for a very, very quiet radio. Well, it'd be better if one of these was really bad. Wasn't it this one? This one tested surprisingly bad. Why don't we put this in another tester? Give them another chance. I feel like testing tubes. Okay, let's bring in the next tester. This is another favorite tester of mine. I have quite a few tube testers. And something my wife is very proud of, the number of tube testers we have. Let me just plug them in here. Turn on some power. And turn on this guy. Okay, this one's a little different than the other tube tester. This one is a dynamic tester, and one of the reasons I wasn't using it is because it's very hard to see the dial here for you. Let me just douse the lights here. See if we can make it a little more visible. Yeah, not so good. Okay, don't worry about that right now. We want to set this guy up for 12 SQ7. So we'll look for 12 SQ7. 12 SQ7, there it is right there. 12 SQ7. Set the voltage setting to 13. Signal level 1. Yeah, I was going to say this is a dynamic tester, so The other one just kind of tests how much current will go through the tube given certain parameters the tube is operating under that the tube tester sets up. It doesn't try to imitate a radio in any way, shape, or form. And neither does this. This is not like a radio in a box and you're making it like a radio and plugging the tube in. That's not what's going on here. These things have very efficient circuit designs. There's not much components in here, piles of wires and switches, and not much else under these things. And they've developed, the makers of these things developed techniques to apply voltages to the tube that would resolve the value that they want to measure. In this case, it's transconductance or mutual conductance, or what do they call it on this tester? Mutual conductance, they call it. So, and that in effect is the ability of the tube to amplify, given the circumstances it's put under here. So something about these tubes, when you measure the transconductance or the GM or whatever, that value is not fixed by the tube. It's not a physical thing. So how you operate the tube can vary the measurement of the transconductance or mutual conductance or whatever they want to call it today. So the thing to do, and you're going to test the tube in this tester, is to look at the number this tester expects up here and judge from that. You cannot transfer these values from tube tester to tube tester. So if this tube tester says this guy's mutual conductance is 2500 and I put it in another tube tester and I test it and it says it's 3000, you say, well, what is it? Is it 2500 or is it 3000? Well, it's 2500 in this tester and it's 3000 in the other, and it's 2250 in your radio. It's not a fixed thing. Okay, enough speeching on that. Let's set the numbers. So signal level 1 bias is the low setting 18. So, and then the upper numbers are 25100, 25100. The lower numbers 3760, 3760. The sensitivity is set to 37, and the plate connection is F. For this tube to be okay for continued service, it has to be above 760s. This is 1000 where I'm pointing. 760 is about here. So I know you can't really read the panel values. You can almost read them. Okay, everything's good. Voltage is good. In you go. Which one of these? How about this one? Put them in that one. So this also performs a leakage test. I think every tube tester has a short or leakage test in it, because if you go to test a tube with a short circuit in it, you may damage your tube tester. So you got to find that out before applying the full test. Okay, and here's the test for leakage. In this case they call it leakage, they don't call it a shorts test. And you just read right off the meter here. So the meter should not move up. Is it going anywhere? No, it's going nowhere. Fantastic. Okay. Apparently this particular model of tube tester has a characteristic where some of them, when you perform this particular test, the meter comes up always, due to something going on inside the tube tester. Mine doesn't do that. So we're ready now. We're in the test position. We're ready to do the GM test. And remember, it's supposed to come up above my finger. Way over. The other tester, this tested kind of weak. Not so much here. Now we're going to do the diodes. Okay, to do the diodes, a different setup here. I don't think the tube should be in when I'm changing these numbers. 2013P. 2013P. 0760. 0760. 48. Switch to A. P1, P2. There are two diodes in here, or then you could think of it as having two plates for diodes. It could be three plates in this tube, but two of them are for diodes. So there's a P1, P2, it's a plate 1, plate 2 switch, and the way they set up this tube tester is for tubes that are like this, where there's multiple arrangements in the tube. You can work your way through them with these switches, right? Cathode, plate, and grid switches on this tube tester. Okay, she's got to be warmed up. We'll do the, because I changed these, we'll do the short again. Nothing at all showing up. Now we're going to push this button here, rectifiers and diodes. And for a diode to become good, or to show up good, it has to get past this little diodes OK, right where my thumbnail is. Right on the edge. Right on the edge. And the other, so now we do plate 2. Now we do the same test. That's actually below the point, it's below. I think we're probably going to end up putting a new one of these in. So the process here now would be to operate the radio with the old tube, put in the new tube, operate the radio, and see if there's a dramatic difference or not. I think that's what we got to do here, because I'm really sort of getting the indication this guy sucks. That's kind of what I got. Yeah, he looks so nice though. Okay, we're going to find another 12 SQ7, then we'll do the test. We'll see if he's a culprit. It's part of a gang, a bad gang of tubes. Okay, so I've got a potential alternative 12 SQ7. It came out of my box of 12 SQ7s there. Let's just test it out. So I need shorts. Watch on the meter now. So I've changed the lighting in here so you can see the meter. No shorts. Okay, now we're set up right now for doing the diodes. So we'll do the diode, and it's well up into the diodes OK range. Other diode, same thing, well up into it. Now we'll set up for the triode. This looks like it's going to be a good one though. So 18L 25100 25100 25100 3760 3760 37 F. Okay, we're ready. Some of these tube testers that have a couple settings for the same tube, you can leave the tube in and change the setting. Only when you push the test button are voltages applied to the tube. But other tube testers aren't like that. And in the middle of going from one setting to another, as you rotate these controls, you can have undesirable effects take place. So, okay. So you need to pull the tube out, and I just can't remember which tester is which. I believe the Stark 966, you leave the tube in. Stark 966, a very, very popular tube tester. We're ready. This has got to, let's just see, 760. So again, 760 is about here. Wow, look at that. Wow, okay, so this tube is dramatically different than the tube that's in the radio. So now we're going to test the radio with one, then the other. And it has to be the most difficult tube to put in and take out, doesn't it? And I can't really see what I'm doing here. Yeah, it's very dark for me. The camera, compensates all the time, of course. So go in. Okay, you're not really supposed to see this part where I can't put a tube back in the socket. There we go. Okay, so this is the original tube set. Everything kind of original. Switches on. Power coming on. Everything's okay. Good. Power comes on. You can see the dim bulb doing its thing in the background. And we want this to be full voltage, so we're going to put it up. 115 volts. The volume's about 2/3 of the way up now. We're on the broadcast band. Okay, volume going all the way up. Okay, so the volume was about halfway. Now it's full. Tune. So you're hearing it. It sounds like it's receiving. Sounds like it's receiving okay, but it just has no volume in the output. Okay, you've heard it. Power off. Now I'm going to pull that tube out of there. And we're going to put in the alternative tube. I'll leave the radio turned up full. Well, maybe I won't. Here, where's the screwdriver? Here it is. Here it is. Okay, come on out. Wouldn't you know, the best dressed tube is the worst actor? Is that kind of a rule in life? Watch out for the people who are really well dressed. They're trying to fool you. He looks beautiful, but his guts are bad. Bad guts. Okay. Now the super good replacement is in there. Well, I don't know about super good. The very good. Very good replacement is in there. I am going to turn the volume back a bit because I just don't want to get blasted. We can always turn it up. We know where it was turned. Full. So we can always redo that. Here we go. Dim bulbs reporting normal. What do we get this time? Should have put some money down. I would say 25 cents says stronger, but not good enough. So at this volume setting, it sounds very similar to the maximum, the old maximum. Here we go. Yeah. This didn't help a bit. Sounds exactly the same. Okay, that's the end of that little experiment. So I think the what we can derive from this is the weak output situation is not tube related. It is something else. Something else. Now, you know what? I'm going to leave the good tube in there, even though it seemed to perform the same as the. Oh, you're so nice looking tube. It's probably better to leave the known to be better tube in there right now. We'll put the not so good tube over here. Maybe he's heading back in the radio eventually. Because I think one of the things we got to keep in mind when we're doing this kind of stuff is that back in the day when all this equipment you see and my tube testers and all that were current, the business was selling parts and service. And one of the biggest parts and the easiest to service, vacuum tubes. So the tube testers, if they didn't help you sell tubes, you probably wouldn't want that tube tester. Yeah, help you sell tubes. Okay, I think that's it for today for me too. I'm going to stop here. And tomorrow we will start pursuing the capacitor replacements, and we'll try to do it in a way that we first get the most likely one to interfere with the volume of the radio. We'll just try to work our way through the capacitors as best I can. I mean, I don't know everything. So I will just try to take that approach and see how it works out. Thanks a lot for watching, and have a great day. See ya.